Hello everyone, I'm Lorenzo Nielucci from the University of Florence and I will present our work that is titled Zero-Shot Composed Image Retrieval with Textual Inversion. Before moving on, I want to thank my colleagues Alberto Baldrati, Marco Bertini and Alberto Del Bimbo. Let's start from the task. What is composed image retrieval? It is a subtask of image retrieval in which the goal is to find images that are visually similar to the query image but incorporate the changes specified in the text. There are two main limitations in the state-of-the-art for composed image retrieval. First, the reliance of existing approaches on expensive, manually annotated datasets limits their scalability and broader use. Second, existing datasets comprise a large number of false negatives, that is, images that could potentially be ground truths, but are not labeled as such. Our work addresses these shortcomings with two main contributions. First, we propose SERL, a method based on CLIP that tackles composed image retrieval in a zero-shot way, thus without the need of a labeled training dataset. In addition, we present CIRCO, the first benchmarking dataset for composed image retrieval with multiple annotated ground truths and reduced false negatives. Our work is based on the textual inversion technique. The term textual inversion refers to the process of expanding CLIP vocabulary by defining a new pseudo-word S star, which contains the visual information of the image, while residing in the CLIP token embedding space. Given an unlabeled dataset, SER training involves two stages. In the first step, we generate a pseudo-word token for each image with an iterative optimization-based textual inversion technique. This technique is proven to be effective, but given that it is performed in an iterative way, it is too slow to be used at inference time. Therefore, to retain the expressiveness while achieving a negligible inference time, we propose to train a textual inversion network by distilling the knowledge encapsulated in the pre-generated tokens. After training, we obtain a lightweight network capable of performing textual inversion in a single forward pass. At inference time, given a multimodal query composed of an image and a text, we start by inverting the image with a textual inversion network. Then, we concatenate the pseudo-word S star with the query text. Finally, we leverage CLIP common embedding space to perform the retrieval. To support research on composed image retrieval, we present an open domain dataset named CIRCO. CIRCO is the first dataset with multiple annotated ground truths. Thanks to the zero-shot capabilities of SERL, we can leverage it during the annotation process to reduce the number of false negatives. Let's take a look at the results. From the table, we can see that SERL obtains state-of-the-art results on three different datasets. In particular, we notice that our approach outperforms the previous zero-shot composed image retrieval state-of-the-art pick-to-word, which was presented at CVPR 2023. In addition, we want to highlight that SERL is trained on just 3% of pick-to-word data. In conclusion, we address the main limitation of existing approaches for composed image retrieval, which are limited by their reliance on expensive labeled datasets. We presented SERL, a method based on CLIP and textual inversion that tackles composed image retrieval without the need of a labeled training dataset. SERL achieves state-of-the-art results on three different datasets. To support the research on composed image retrieval, we presented CIRCO, the first dataset with multiple annotated ground truths and reduced false negatives. Thanks for your attention. Feel free to reach out if you have any questions. Ciao!